Okay, this is lesson 3.4, using similar triangles. When two angles in one triangle are congruent to two angles in another triangle, the third angles are also congruent and the triangles are similar. Remember from similar figures when we did that lesson that the corresponding angles are congruent and the corresponding side lengths are proportional. So we're going to use this information in this lesson. In the example given in this key idea, you see that triangle ABC is similar to triangle DEF. So the first example we're going to do is to tell whether the triangles are similar, and we'll explain. So you'll want to solve for x, and what we're looking for is at least two of the angles to be congruent, and then we know that the third one is also congruent. So for the first one, I will take 28 plus 80 plus x is equal to 180. I'll simplify by combining like terms, so I get 108 plus x equals 180. Solve for x by subtracting 108 on both sides. And in the first triangle in the first example, x is equal to 72, so that's the missing angle. Now, you can see already in the yellow triangles we have one angle that is 28 and another angle in this yellow triangle that is 28. Since we solved for x and we got 72, unless y could be equal to 72, so it's always a good idea to check the other triangle. So we'll take the 28 plus 71 equals, plus y equals 180 in the second triangle. Combine the like terms and we get 99 plus y, and I can already tell that it will not, but I'll subtract 99 on both sides, and y in this case is equal to 81. So no, they are not similar because the triangles do not have the same angle measures. Let's try the blue triangles. So 66 plus 90 plus x will equal 180. We'll combine some like terms here. 156 plus x equals 180. Subtract on both sides to get the value of x to be 24. So this angle equals 24. So we have a 90-degree angle and a 24-degree angle. We have a 90-degree angle and a 24-degree angle. We'll go ahead and solve for y, but we're going to go ahead and make the assumption that it is equal to 66. Therefore, these triangles are similar because they have three equal angle measures. So we'll just check our work just to be sure. 90 plus 24 plus y equal to 180. Combine the like terms to get 114. And then solve for y. Since y is equal to 66, the answer is yes. They have three equal angle measures. Remember to pause the video if you need to write down. Okay, example 2. You plan to cross the river and want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. A, we're going to explain why triangle ABC and triangle DEC are similar. And then B, we're going to find the distance across the river. So for part A, we need to start evaluating some things. We see that angle B and angle E are both 90 degrees. We also notice that angle ACB, and remember the vertice we're looking at is in the middle, ACB, and angle DCE, notice that the vertice is the same, C for both, are vertical angles. And vertical angles are equal. So since there are two angle measures that are equivalent inside these triangles are similar, and therefore their side lengths are proportional so that we can find the missing side. So I'll finish writing this. They are vertical and congruent by definition. So that brings us to part B. So then we'll say the triangles are similar, because in part A we needed to know if they were similar so we could tell if the side lengths would be proportional. So since they are, we can now set up a proportion. I'm going to use the missing side, x, which is the height of the smaller triangle, and put that over the height of the larger triangle of 60. And then I'm going to have the base, which is 40 of the smaller, so remember we're keeping that in the numerator, and the base of the larger, which is 50. And through solving for the missing variable through cross multiplication, we'll get an equation that looks like 50x is equal to 40 times 60, which is 2400. Divide both sides by 50, and we'll get the missing side length, x is equal to 48 feet.